Yeah, guys, good morning. Let's start the session. Oh, let's continue. So here is our example. Okay, let's move on. This operation is what we have discussed in the last class. Okay. Basically, the example is we want to save a category. Basically, our example is we would like to save a category. Whenever we save category, we would like to save the products of the category also in the database because we are providing one-to-many mapping. We are providing one-to-many association. So one category has a list of products. Our intention is whenever we save a category in database, the products of that category also we want to save it in the database. Simple. That is called one-to-many. We are providing association as one-to-many. Clear. So these are all good. Okay. Now next, in our DAO, actually yesterday 3 operations we are implemented, 3 operations in the last. We have implemented 3 operations. One operation is about save a category. Second operation is fetch the details of a category based on the ID of the category. And the other one is remove a category based on ID of the category. Means what? Yesterday we have only tested save category. Today we will like to understand about the remaining operations also. What are the remaining? Fetch category and remove category are the operations. Okay. So let's go ahead and understand about the fetch category operation and also about remove category operation as well. Sure. We will discuss. I want to keep all this code like whatever that I did yesterday into comment. This code, I want to keep it in a comment. Because this is what we did yesterday. We have created one category entity. We have created one category entity and then we have created product entities. Product entity, again product entity, one more time product entity. So we have created totally 3 product entities. And yesterday what we did actually, we have added all these product instances to the list, a collection object. After that, then we have set that collection object to the category object. So we can say category has a list of products. So for that, first I created a list. First I have created one list. I have added all the product objects to the list. Each product object contains ID of the product, name of the product, image of the product. So there are 3 attributes in the product entity: ID, name, and image. Image is nothing but I took JPG file. Even you can take PNG file or even GIF file also, but not a BMP file. BMP file in the sense bitmap file. Like if you open the paint and you draw some painting, if you open the Microsoft Paint and if you do some painting, that is called bitmap image. Those images we cannot store in the database. That's for sure. Only we can store PNG images or JPEG images. That's called JPG extension. Otherwise, GIF. Okay. Graphical interchange format. GIF. Okay. JPG, actually JPG. Okay. Joint Photographic Expert Group. That's called extension of JPEG. And other one is PNG, Programmable or Portable Network Graphics. PNG stands for Portable Network Graphics. GIF stands for Graphical Interchange Format. These abbreviations also will be asked in interview. We'll ask, tell me what JPEG stands for. 99.99% doesn't tell any answer. Okay, otherwise they will tell their own abbreviation. JPEG stands for Joint Photographic Experts Group. GIF stands for Graphical Interchange Format. Okay. PNG stands for Portable Network Graphics. PNG, JPG, and GIF. These three types of images we can store in the database, not the BMP files. Okay. Good. So, yesterday, as part of the one-to-many relationship, what we did, we have inserted or we have persisted a category in database. And we know that that category has a list of products. So what happened whenever I inserted or persisted a category in database, along with the category, the list of products are also persisted in the database because we provided one-to-many association. We mapped one-to-many relationship. That is the reason why it is persisted, right? Now, today, we will understand about the next operation as what? Fetch category based on ID of the category. Of course, in my table, I have only one record in the categories table. This is ID of the category 12101. Category name is electronics. Okay. And these are the products of the category. This is the foreign key column. This column is actually represented in our application as a join column. And if you look at the foreign key value, I mean the data in the foreign key column, it is 12101, 12101, 12101. So what you understood? This is the ID of the category, right? Means what? These three products. Okay, these three products belongs to same category. This is what we got yesterday. And you know how to open the image in Workbench. Okay, you have image here, but you are not getting the image in this column. You right click there, open value in editor, click on image tab here. You can see this is one image yesterday we have inserted in the database. Okay, and for television, we have inserted this image in the database. Okay, and for micro oven, this is the image we have inserted. Okay, I'm showing some images now today because we are retrieving. We'll see whether we are getting the same image from database or not. Okay, let's go on. Now we want to understand calling this method. Which method I would like to call? Fetch category is a method I would like to call. I want to call this method. Method name is fetch category is a method I want to call. Pass the category ID, which returns me, whenever I call this method, it returns me the category object, an object of type category entity. Means category object in our terms. In our terms, it's called category object. Na? So let me call that category entity, say C entity, some reference variable equal to DAO dot fetch category of 12101 ID of the category. Basically, before I start writing the remaining code and all, I want to explain you. First of all, if you look at my category entity, these are the two new annotations we have added. One is @ one-to-many, @ join column. Join column is foreign key, and one-to-many is one-to-many association. To map one-to-many, this is called one-to-many field. This variable is called one-to-many variable. And cascade attribute, you know already what it do. Cascade operation, cascade attribute, okay, it represents the operations that must be cascaded or propagated to the associated collection. So what operations all represents? If I had a cascade type all, it represents what? Insert, that is called persisting, deleting, merging. Merging means updating, refreshing and detaching. These 5 comes under all. But we know this annotation has another attribute called fetch. There is an attribute called fetch. Fetch represents a fetch type. Fetch type in the sense whether the associated collection should be early loaded or should be lazy loaded. That's called fetch. Suppose if I don't write fetch, the default fetch attribute is lazy. Fetch type is lazy. Fetch type dot, I can write lazy. Default also by default is lazy only. I'll keep the cursor here. You can see whether the association should be lazily loaded or must be eagerly fetched. It is optional. It is optional. The eager strategy is a requirement on the persistence provider runtime that associated entities must be eagerly fetched. The lazy strategy is a hint to the persistence provider at runtime. Okay, what's the default value? Fetch type dot lazy is a default value. If I don't write fetch type, fetch is equal to fetch type dot lazy. For example, if I remove this, what is the default fetch strategy? Lazy. Lazy means the associated collection should be lazily loaded, not early loaded. What does it mean? If you take our example is what? We have a category. We mapped about one category with a list of products as a one-to-many relationship. We provided one-to-many relationship as what? One category has a list of products. If I fetch the category from database, list of products are not fetched. Only categories fetched, but not the products. Okay, if fetch type is eager, then when I select the category, products of the category also will be selected. The list of products are also selected from the database. That is called eager. But what's the default fetch type here? Lazy. Let's see by looking at the query, what is a query that Hibernate is executed on the database? You can identify this. So I want to run this code now. You can see the query over here first. Look at the query. What this query is selecting? ID of the category and name of the category. It's only selecting what and what? ID and name. That's all from this table. But what about the list of products of this category? They are not selected because what's the default fetch attribute? What's the default fetch strategy? Lazy. Look at identify the difference. Let us open this. Now, in that annotation of what's the annotation name? @one-to-many. In this annotation, we have an attribute called what? Fetch. Fetch is equal to fetch type dot eager. Let's see the difference. Run this code. See the query difference. Now see the query difference. What happened earlier? Only category ID and category name are selected. Correct? But now this time this query is selecting what now? category ID, category name, foreign key, product ID, product image, product name. You are getting my point? Means tell me, by using this query, means by adding this fetch type eager, you have some query difference now using left outer join. You know what joins in SQL, right? When you have data in 2 tables or 3 tables and you want to retrieve the data with a single query, then you have tried join statement now. By default, it uses what type of join for fetching the category and its products? Okay, it is called left outer join that Hibernate is using, right? You can see here left. You know already the 3 types of joins, right? What are the 3 types? Self join, inner join, and outer join. What are they? Self join, inner join, outer join. Again, outer join is 3 types. What are they? Left outer join, right outer join, and full outer join. Got it, huh? Nice. So, I would like to, guys, I would like to tell you that. Yes. Observe here. Okay. Now, coming to the point. These are all my fetch type eager and fetch type lazy. Okay. If it is fetch type lazy, that's a default value. What is the default value of the fetch type attribute? Lazy. If a fetch type is lazy, then when I select a category, its associated list of products are not selected from the database, but they are selected later when they are required. But that is called meaning of what loading? Lazy loading. That's what the meaning of writing lazy loading, right? But I want to change to what now? Eager. Eager. Eager means what happens now? Along with the category, the products of the category are also selected from the database. That's what eager. Okay. Here, I want to display name of the category. Name of the category, I know category ID is 12101, but what I want display name of the category. So system.out.println category name. So how can I able to display the name of the categories? I can display the category as C entity dot, what is that? Get category name. Entity category name is okay, but this category has products now. So I also want to display what? Products details. Each product is containing when I call get product image, what I will get? Bytes. What I will get? Byte array. Image is a collection of bytes now. I'm going to get a byte array, but I cannot understand the byte array, right? If I convert that byte array into an image, then I can able to see the image, right? So what should I do now? I have to convert the bytes of an image to image file. I have to write these bytes into the file. That's what the meaning now. What I should do? I have to write these bytes into the file. I have to write these bytes into the file. That is called meaning of converting these bytes to an image, so that we can look at that image and we can see, okay, this is the product I have in the database. So what I do is, I'm not writing the code for converting every image. Only for one image, I will write the code. Later, you expand it to write for the all images. Look at this. First, list of product entity LST is equal to C entity dot get list of products. I am getting the products of the list category. How to get the list of products of the category? By calling the getter method. What this list contains means what are the elements in the list? What are the elements in the list? Product objects. What each product contains? ID, name, and image. ID, name, and image. 3. I don't want to write a for loop. I can write the for loop here. I can write the for loop, no doubt. I can write a for loop here. For each loop, I can write. Or I can write Java 8 for each method is also there. I can write even that one also. But you need to think and write that. I don't want to give that to you. I want to take only one product, first product. Only one object from the list. If I want to take a particular object or element from the list, I can pass index, because you know that list is ordered collection. First element in the list has index 0. Second element in the list has index 1. Because you know, list is a ordered collection. Set unordered collection. List is ordered collection and allows duplicates. Set unordered collection and does not allow the duplicate values. Does not allow the duplicate values means what? If I add a duplicate element, it doesn't throw exception. It will simply replace. It will replace the old item with new item. Okay. Let's go ahead. Product entity P entity equal to LST dot get of 0. So what I'm reading here? What I'm reading? Read the first element of the list. I'm reading all elements or only the first element? First element only. First element only. SOP. SOP. Understand? SOP. Product ID. P entity dot get product ID. Right, guys? SOP. Product name. P entity dot get product name. My question is, ID and name is okay, but product also has an image, na? But image is a collection of what? Bytes. Okay, you know, you can see the property. What's the property name? Product image. Product image. It is, what is the type of this variable? Byte array. Byte array. So, byte array. Okay. Say bytes of image, some variable, any name, equal to P entity dot get product image. What I got here? Bytes. What should I do? I need to convert these bytes to image file, into file. You are getting my point? Into file, I need to write these bytes. Okay, I'll do one thing. In my system, in a D drive of my system, I want to create a new folder. Folder name is image from DB. What is my folder name? Image from DB is my folder name. Currently, this folder is empty. Just now I have created, no images are there here. What I want to do now? I will go to my code. In my code, I will write like this. I will write like this. File, some file, any file name. File F1 is equal to new file of file path d:// image from DB. I told you how to use / in Java. / forward slashes is a single, backward slashes are double. And the image name I want to use like mobile from DB .jpg. Okay. Mobile image from DB. Otherwise, I'll take mobile underscore image underscore from DB. From DB. Now, file output stream. What stream? File output stream is to write data into the file. File input stream. Read data from the file. Got it now? Right. File output stream. FOS equal to new file output stream of F1. So what is the purpose of the file output stream? It is to write the data into the file. FOS dot write bytes of image. Means what this method will do? We'll write these bytes into this file. What's the file image for the file path? D image from DB mobile image mobile underscore image underscore from DB dot JPG. That's all. SOP please check the image at F1 dot get absolute path. Means I want to display output like that. Please check the image at so and so location. Let us run this code. I would like to run this code. Now see, what is the category name displayed? Electronics. What is the product ID displayed? 2208989. What is the product name? Mobile. Where can I check the image of this product? At a D drive, image from DB folder, mobile image from DB.jpg. Let's go there. Here I am. This is a D drive, image from DB, mobile image from DB, right? You open this image. Open this image using photos or paint, something like that. Now this is the image I got from database. This is the image only what I have inserted. This is the image I retrieved even from the database also, right? So this is, here I'm repeating loop for each and every product of the category or only one product of the category. Later you write the code for remaining, okay? Let's go ahead. Now I want to keep again this code also into comments. Okay. So here, what I called here, what's the method I called here for DAO? Fetch category. Fetch category is a method I called. Next one I want to call, I would like to call the next one. What's the next one I want to call? Remove category. Sure. Now, how can I remove this category? DAO dot remove category of 120. What is the category ID? 12101. What is 12101? ID of the category. But what happens when I remove? It's not removing only category. It will also remove products of this category, because there is a association relationship is available between the product and category and products. What happens when I remove the category? Products are also removed. Means now my tables are going to become empty, because in my table there is only one record I have. In products I have 3 records, but all these 3 products are belongs to same category. Na? What will happen now when I execute the remove category operation? What is removed? The product is, all the products are also removed from the DB along with category. Why? Because we already mapped what type of relationship. We already mapped what type of relationship? One to many. Okay. Our requirement is what? When we do an operation on category object, we want to propagate the same operation on list of products. That is the reason why we provided what kind of relationship? One to many. Otherwise, you no need to provide any relationship. But why you provided the relationship as one to many? Because you have a requirement. What is my requirement? Whenever I do an operation on a category, the same operation I want to propagate on list of products also. Because this category has a list of products. This category has a list of products. Whenever an operation is done on the category, the same operation I want to propagate on products. What happens if I remove the category? Products of the category also will be removed. Sure. Let us run this. Okay. And what's the message I got? Category with the products is removed from database, because in my DAO method, I've written an SOP statement like that yesterday. So today you can see the output. What about this category table? Empty. No records are there. Only columns, headings are there. But I don't have any records. Okay. What about the products? Only columns are there. But I have no records. I don't have records. Means what you understood? What happened here? When I remove a category, products are also removed. Why? Because we are applied one-to-many relationship. When you apply one-to-many relationship, what happens? When you remove the source object, who is the source of the operations? Category object. I am doing operation category object. Na? Source is the category object. When you do operation source object, the same operation is affected on the target objects. Who are the target objects here? Products. That's all. This is how you can understand our DO operations, and you can understand the relationship called one to many. So as per our example, we have provided, or we have applied one-to-many relationship between what and what? Category and products. What is our relationship? One category has multiple products. Whenever you want to provide one-to-many relationship, whenever you want to provide one-to-many relationship between a category and the products, what should I do? I have to add that product objects to a list, collection, list or set. Then after that list object you can set to the category object. Now we can say that category has a list of products. This is called what kind of relationship? This is a way how to apply one-to-many relationship. Remember that. So how to apply one-to-many relationship between one category object and multiple product objects? First add the product objects to a collection. Then set that collection to the category object. Now what we can say, category object has a list of product objects. We can say relationship is one to many. One to many. Got it, right? One to many. Okay, one to many. Good. For example, one customer. I want to provide, for example, I want to provide one-to-many relationship between a customer and a group of orders. What kind of relation I want to provide? One-to-many relationship between customer and products. I want to provide one-to-many relation between customer and products. Customer and orders. Then tell me how to provide one-to-many relationship between customer and product orders. First, add the orders, order 1, order 2, orders to the collection. Then set that collection to the customer. Now we can say what customer has a collection of orders. It is called what relation? One-to-many. One-to-many, right? So customer has a collection of orders. Category has a collection of products. Customer has a collection of loans. This is called what? One-to-many. One-to-many. Are you getting what? Okay. For example, a book has a group of or collection of publishers, or a publisher has a collection of books. What's the meaning of publisher has a collection of books? One-to-many between what and what? Publisher and books. One publisher has published multiple books. What kind of relationship? One-to-many. This is a way to provide one-to-many. Good. Let's start with the second one. Understanding one-to-many is a basic relationship to go into next understanding the many-to-one or many-to-many and one-to-one. That's the reason why everybody, to understand the relationships, understanding this one-to-many is a critical one. If you know one-to-many, then only you can understand all the remaining. That's the reason why everybody should get the clarity on how one-to-many relationship can be applied between entities. These are called entity relationships. Between what and what entities we are providing one-to-many relationship here? We are applying one-to-many relationship between category and products. We have category entity and we have product entities. We want to define what kind of relationship? One-to-many. One category has a collection of products. Collection can be list. Collection can be set also. Or even we can use map also. But generally we use either list or set, any one of the two. Right? Good. Now, guys, think about it once. And if you have any query, write in chat box. Okay. Okay. Let's go ahead, guys. Okay. Okay. Let's go ahead, guys. Now, whatever the relationship so far we discussed is a one to many. Now let us see how to provide many to one. Now today we will understand about how to provide many to one. It is not one to many, it is many to one. The next one is many to one. Okay. Okay, let's start about how to define many to one relationship between the entities. Actually, if you take, for example, one category, we applied what kind of relationship between category and products? One to many means one category has a collection of products. We want to apply one to many relationship between category and products. That is one to many. But now we want to understand how to define many to one. Okay, many to one. Actually, one to many and many to one having a small difference. The difference is source and target of the operations will be interchanged. Earlier, who is the source of operations? Who is the source entity to execute the operations? Category. And who is the target entity? Product. Product is our target entity for operations. That is one to many now. Now many to one. One to many, many to one. The outcome will be same. Means the database output will be same. But source and target are interchanged. See, for example, I want to take like this now. What I want to take? I would like to take one customer class. And I also want to take one loan class. Okay. I want to define many to one. Many to one in the sense, I would like to set, or I would like to apply relationship from multiple loans to single customer. Many to one. Na? The same thing even other way what I can apply. One customer has a multiple loans. So it is called what kind of relationship? But if I apply one to many, which entity will be the source for operations? Who is the source? Customer. And who are the target objects of the operations? Loans. But my requirement is what? I would like to perform operation on loan entities, not on customer. But when I do an operation on loan entity, then I would like to apply this operation on customer also. Means in my application, which entity I want to use as a source of operation? Which entity I want to use like a source of operation? Loan. Which entity I want to use like a target of the operation? Customer. So if you want to interchange what and what, source and target, then you need to provide what kind of relationship? Many to one. Many to one, which is nothing but what? We are mapping many loans to one customer. In other way, what we can say? We can map one customer to many loans. You're getting my point or not? If you map one customer to many loans, which entity will be the source for operation? Customer. But my requirement is what? I want to perform operation on loan. I want to propagate it on customer, which is nothing but what? I want to apply many to one. Means what? I am mapping relationship between many loans to one customer. Means what? I am setting customer to many loans. Many loans are there. I would like to set the same customer to multiple loans. Say, for example, loan 1 dot set customer, example of customer. Loan 2 dot set customer, again same customer. Loan 3 dot set customer of customer. Right? So what are understanding now? Loan 1, loan 2, loan 3. 3 loans. But what I'm setting? Same customer. Means what we are setting? Many loans to one customer. This is called many to one. Now, who will be the source of operations? Who will be the source of operations? Loans. And who will be the target of the operations? Customer. If I apply one to many, then who will be the source of the operations? Customer. And who will be the target of the operations? Loans. But I am defining many to one relationship, not one to many, because my requirement is what? My requirement is what? I would like to perform an operation on CRUD operation on loan, not on customer. But when I perform any CRUD operation on the loan entity, I would like to perform the same operation on customer. Nothing but I want to propagate that operation onto the customer. Then I need to define what kind of relationship? Many to one. Many to one. Let's see how to define many to one. So my tables I'm using like this now. First I'll delete this. Let me talk about. Okay, let me talk about tables. This is customer table. Let's say TBL underscore customer. Let us say table name is TBL underscore customer. Understand? TBL underscore customer. Okay, what is TBL underscore customer? It is a customer table. It is a customer table. It has attributes customer ID, customer name. I don't want to take many. Customer email ID, customer mobile contact number, and all means code increases. 2 attributes are enough. Cust ID or customer ID. Okay, let us say customer ID. Why not? Next one, customer underscore name. Enough. These are the 2 attributes. Enough to understand the association. Now, which column is acting like a primary key column in this table now? Customer ID. Customer ID will be the primary key column. Customer ID will be the primary key column. Okay. Other table name is loans. TBL underscore loans. TBL underscore loans is what? TBL underscore loans is what? Child table. What are the columns I want to take here? Loan ID. Loan ID. Each loan has an unique ID. Loan type. amount, customer ID. Customer ID. Look at this now. Who is the primary key? Which column is acting as primary key in this table? Loan ID is a primary key. Primary key column. Last column, this customer ID is the foreign key. It's a common column, na? Foreign key. Okay, let's go ahead. You got it, right? What is this now? TBL underscore customer, TBL underscore loans. Okay. What is the, what happened here? This is customer. These are the loans. Now, understand clearly. This foreign key column is called as joining column. Joining column of the relationship. Otherwise, we can call foreign key column. Joining column. But we want to define what kind of relationship now? Many to one. Means what I would like to set? A customer to many loans. Many loans to one customer is called many to one. This is what we want to map. What I want to know? I want to map a many loans to one customer. Means I want to use what kind of relationship here? Many to one. Okay, let's see how the entity classes we can create. Let us find out what are the entity classes for this. First, I want to write entity table. Table name is TBL underscore customer. Public class customer or customer entity. I won't take my class name as simply customer. Customer is one class. Or customer entity you can write. Your choice. Class name can be your choice. Public class customer. ID. ID. Correct? Next what? Column. Column. What's the column name? Customer underscore ID. What is a variable? Create a variable here. Private integer customer ID. Next column. Column name is customer underscore name. Variable I want to create is private string customer name. Setters, getters, constructor, I am not writing them. It's okay. Okay. See, how many columns we have in the customer table? 2 columns. I am mapping this customer ID with the column customer underscore ID because at the rate column is to specify the column name now. Right. So how many columns I have? 2 columns. This is which table? Customer table. What is the entity class name? Customer. I am mapping the customer table with TBL underscore, customer class with TBL underscore customer table. Next one, what is the next entity class I need to create? Loan. Let's start creating loan at the rate entity. At the rate table. Name equal to TBL underscore loans. Public class loan. Loan is my next class. ID. Okay. Column. Column name is equal to loan underscore ID. Private integer loan ID. Column. Column name equal to loan type. Loan type is a string like personal loan or home loan or vehicle loan, like that. Loan type. What's the next property? What's the next property? Customer loan ID, loan type. What's the next one? Column name equal to amount. Double amount only. Actually, column is optional here. Why? Why column annotation is not mandatory? Because the column name is same, matching with the variable name, right? So then there is no need to specify the column name here, right? Okay, but still I have included, no problem. Next one is a foreign key now. What's a foreign key? Customer underscore ID foreign key. I told foreign key is represented with a join column annotation. So there is no variable required to map with the foreign key. You don't require variable to map it with the foreign key. Okay. But each loan has a customer. You got my point? Every loan has a customer. Got my point? So if you want to provide an association between a loan and a customer, okay, normally how do you provide has a relationship in normal Java programming? For example, if two classes are there, A and B, how do you provide has a relation between A and B? You have to create the reference variable of class B, reference variable of type class B inside class A. If you provide one class reference variable inside another class, then we call it as what type of relationship? Has a relationship. Now tell me, every loan has a customer now? Means what kind of relation I want to provide? Has a relation between what and what? Loan and a customer. Tell me, if I want to provide has a relation between a loan and a customer, then what should I do? Create a reference variable of customer class inside loan class. Yes. Private. Look at this. Yes, guys. Private. What is it? Customer. Customer. Have you understood? Have you understood this? Tell me. Loan has what? Customer. It is called what relation? Has a relation. Loan has a customer. How to provide has a relation? By creating reference variable of one class inside another class, so that you will get what kind of relationship? Has a relationship. Good. Good. Nice. Listen here. Now we call my question. Why this? Why I have created this customer variable in this loan class? Why I created this customer variable? This customer variable I have created inside this loan class to provide many to one relationship now. This is called many to one variable. So how to declare? How to declare that this is many to one variable? We have annotation. At the rate many to one. At the rate many to one. Okay. Our intention is what? As per my example, who is the source of my operations? I mean, who is the source entity to perform operations in my code? Loan. And who is the target of the operation? Customer. If I perform insert operation, or if I perform delete operation, or if I perform update operation, you got my point? You got my point? What's the requirement? If I perform insert operation, or update operation, or delete operation, whenever I do this operation on loan, I would like to propagate this operation on customer. So for propagating the operation, cascading, that's what the meaning of cascading. Okay. To cascade these operations on customer, to cascade these operations onto the customer, I should add one attribute here. What's the attribute? Cascade equal to cascade type dot all. So what this cascade attribute? Cascade attribute represents what? Cascade attribute represents the operations that must be cascaded onto the associated entity. Tell me what operation that must be cascaded onto the associated entity? All means inserting, updating, deleting, refreshing, detaching. In place of all, if I change to persist, then okay, what operations that must be cascaded onto the associated entity? Only insert, not the update and not the delete or detach or refresh. But all represents all these five. All these five. I'll let all. Next. It's a constant. Next one is what? At the rate join column. What is that? At the rate join column. At the rate join column. Join column is to specify what? Foreign key. Tell me, join column means foreign key column. Who is a foreign key? Who is a foreign key column for this relationship? Customer underscore ID. Customer underscore ID is a foreign key. Because you know the foreign key column name is customer underscore ID, na? Yes. This foreign key refers what? Always, you know, foreign key column will be in child table. But that foreign key column refers primary key in the parent table. Primary key in the parent table, right? So then tell me, this customer underscore ID is a foreign key. This foreign key refers customer underscore ID in the customer table, right? Okay. Okay. Done. So what are the two annotations I have used or applied on this customer variable? Many to one and join column. Join column is annotation represents the foreign key column of the relationship, right? And many to one representing that the relationship is many to one. So how to apply many to one relationship now? What should I do for applying many to one relationship? Okay, we need to create the reference variable. Reference variable of what? Reference variable of target entity in the source entity class. Who is the source entity of these operations? Loan. Who is the target entity of these operations? Customer. So what should I do? Create a reference variable of target entity class in source entity class. In source entity class, create a reference variable of target entity class. That reference variable is called many to one field or many to one variable. So how to declare that it is a many to one variable? By using this annotation. What's the annotation? At the rate many to one. And what's the other annotation? At the rate join column. Join column is to specify the foreign key of the relationship, right? So coding part, you got annotations now. Like one to many, many to one also has fetch attribute. But the default fetch attribute value is eager. In one to many, the default fetch type is lazy. In many to one, the default fetch type is eager. That's a difference. Okay, right. Here also we have fetch attribute. Cascade attribute is there and fetch attribute is also there. Got it now? Right. So finally, okay, you got how to create entity classes. And we'll start writing the code and operations in the tomorrow's class. Okay, that's for now. Yeah, guys. So is it clear whatever that we have discussed in the session today? Is it clear? Have you understood the concept? Okay. Please type C RN. The application I'll post now. That example of one to many, whatever we discussed today. That example, I'm going to post it as a zip file today now. Now I'll post it immediately after the class. You please go ahead, okay? Try to see the code, whatever the code I have written. And please try to understand about how one-to-many relationship can be provided. Okay, now? Right. Good, good, nice, nice. Thank you. Thank you. Thank you. Okay. That's it for today. We'll continue on tomorrow. Okay. That's all. No, 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 no.